Let's take a look at this problem. We got x to the 1/4, y to the 1/2 over 16 x to the 5/4, y to the 7/2. All of it raised to the negative 1/4 power. Okay, now I typically, just as long as you're using valid properties, you're fine of exponents. But I typically try to stick with the order of operations. Order of operations says do what's inside the parentheses first. So we'll focus on that. Within parentheses, we have fraction. So we'll do what's on top, do what's on the bottom. Well, there's nothing to do on top, nothing to do on the bottom. So then we'll handle the fraction itself. Well, 16 we can't do anything with, but here we have x to a power of x to a power. We'll subtract a smaller exponent from a larger one. They already have the same denominator, so I didn't have to do anything there. So for our x's, we're going to take 5/4 minus 1/4, which gives us 4/4, or 1. So we're going to have x to the first power where our larger exponent was, which was down below, right there. Now the y's. We're going to subtract a smaller exponent from a larger one. So we got 7/2 minus 1/2, which gives us 6/2, and 6 divided by 2 gives us 3. So we're going to have y to the third power where our larger exponent was, which was down below. And then we'll put a placeholder of 1 up there. If everything disappears in a fraction, then you always have a 1 there by default. Okay, there's nothing left to do inside the parentheses. So notice we have a fraction to a negative power. So we're going to flip the fraction, take a reciprocal of it. This becomes 16x to the first, y to the third over 1. And then you change the sign of the exponent. It becomes the 1/4 power. Okay, well that 1 can drop away. So that just gives us 16x to the y, 16x y to the third, all of it raised to the 1/4 power. Now, if everything inside of your parentheses is either multiplication or division, and you're raising it to a power, then you can take everything to that power. It's kind of like a distributive property concept. So we're going to take the 16 to the 1/4 power, we'll take the x to the 1/4 power, and we'll take the y to the third to the 1/4 power. So we got 16 to the 1/4, we got x to the 1/4, and we got y to the third power raised to the 1/4 power. Now 16 to the 1/4, I'm going to put that back in a radical form. That'd be the 4th root of 16. And then we got x to the 1/4. Now when you're raising one exponent to another exponent, you multiply the exponents. 3 times 1/4 gives you 3/4. Now 16, if I do the prime factorization of it, is 2 times 2, well, 4 2's. Like that. X to the 1/4. Y to the 3/4. Now our index is 4, the number in the slot right here. So we're looking for a set of 4 of something. Well, here's 4 2's. So the 4 2's is going to come out in front as a single 2. So this gives us 2x to the 1/4, y to the 3/4. And that's our answer.